our first talk with Chris. Chris is actually from Intel. He's a serial entrepreneur and developer who has built and sold 5 emerging startups. He now serves as a chief developer and evangelist in Intel RealSense, focusing on AI, robotics, and stereo depth technology. Chris is also a regular speaker at events stuff like this globally, and I want to have a big applause for Chris. Let's welcome him. Thank you very much.
Thank you, thank you. Oh, thank you. Y'all are very kind, and this is the most amazing drink I've ever had. Oh, thank you. Look at this room. Over 100 people just in this room alone, and not to mention global event. And then you heard Alex talk about the funding opportunities. This is a great time to be alive. I can't believe this. I'm excited for y'all. I'm excited. I saw the AMR walking robot over there. He's so cool. So I'm going to talk to you just a few minutes about what I see on the front line. I'm with Intel RealSense. They're the camera, the robotic eyes. I mean, everyone's heard of Intel. We are spinning out of Intel in a couple of weeks. We're going to be RealSense Inc. You could kind of think about this as a Series C startup with 80 patents, an inventory of products. We just released a brand new facial authentication camera, stereo facial authentication camera. Why? Well, because robots need to see who they're talking to, right? If I ask the robot to bring Chris a beer, it needs to know me, not you. All right? Facial access control, etc. But we've also released a brand new Power over Ethernet camera. I've got it in the back. So really exciting about all these things coming. The D405, has any of you seen this camera before or played with it? Well, a few hands. Well, you're each going to get one on your teams. Intel sponsored these cameras for every robot here on site. It's got a RGB camera on it, 90 frames per second. The depth is a close range camera, 7 centimeters to 50 centimeters with a good field of view. You can see this on the new Gemini robots that just came out. They're right above the hands. We've got tripods for you at this event for you to put above your arm. Why do you need a 3D camera? A 3D camera. Why do you need a stereo camera? 2D cameras this is what it looks like on the left side of 2D cameras. Just kind of a big blob is what the computer sees, people climbing stairs. If you look at it on the right, every pixel, every RGB pixel of the camera has a depth parameter associated with it. So it can easily see that's a row of people, and it can easily see how far away each person is. So what's also more interesting is that when you attach multiple cameras together, it actually gets better. So all of these cameras can sync together and work together to give you even better computer vision. I mean, if this was an AMR contest, we'd talk about VSLAM and localization, but this is exactly what you want for a robotic arm, to knowing what's on the table, what can it pick up, and where do I grab it, and how do I grab it. So the depth cameras, they've got 2 depth sensors on each side. There's an infrared that shoots the beam to help get clarity on the distance of the object, and an RGB camera inside of there for your object detection. This simulates what the brain sees. When these cameras look at something, every robot sees the image clearly like a human. In fact, I would even venture to say better than a human. 60% of the AMRs on the market use RealSense cameras, and 80% of the humanoids use RealSense cameras. And remember that 90 frames per second I was showing you a while ago? Humans can only perceive things at about 60 frames a second. Superhumans like some of you guys are probably 100 maybe. But 60 frames a second. So if you imagine what a robot can do timing-wise, a robot can go into hyper mode and do 90 frames a second and maybe do 2, 3, 10x the speed and velocity of what a human can do. So think about that in your hackathon projects you're doing today. I hate to say it, but replacing human for repetitive tasks is here, and it's coming even bigger and faster. So what are some of the use cases of a RealSense depth camera? I talked about facial authentication. We're seeing this all over airports, ATM machines, robots. We've talked about pick and place. I was answering some questions in the back a while ago by a contestant, I see you, Sid, about scanning. You can definitely do, like, create digital twins with RealSense cameras. There's an open source SDK that also supports Android. So you could attach a RealSense camera to an Android tablet, walk around, and get a three-dimensional scan. Oh my gosh, and this measurement and logistics. When I was a kid, I can't tell you how many gumballs I tried to guess in a box. Well, with the RealSense camera, you could actually get the right answer of what's, the dimensions of a container, how much is in it. We talked about SLAM and depth, et cetera. So lots of market opportunities for the cameras. That power over Ethernet camera back there, 100 meters is the range of that camera from the compute. So if you think about it, like, we're all dealing with very close things, like with this D405 at this weekend's event. But imagine being able to put 100 meters on a camera and lots of cameras. You could do basically real-world Google Analytics in this room right here with something like that. So I'm just throwing out ideas for the hackathon. So what do I see? This is my last slide, then I'll pass it off to the next presenter. But what I see, and Intel talks about this all the time, about lights out automation. Get to the point where, yeah, cobots are cool because they don't hurt people. They work with people. But what we're seeing is that everything's got a RealSense camera on it, whether it be a humanoid, whether it be an AMR, whether it be ARMs, all working together in tandem to communicate and work together safely at hyperhuman speeds, 10x speeds of a human. So with that, I think I'm a judge. So be nice. I'm really excited and looking forward to see what all of you guys come up with. And I'll be walking around, maybe doing some interviews when you're not stressed out with the timing. So thank you very much. Hack away.
Thank you very much.
Thank you.